Okay, last but certainly not least is another colleague from QUT Intellectual Property and Innovation Law Programme, Dr. Hope Johnson, who's going to be ending the presentations in this session with her presentation on intellectual property, climate change and food security.
I've actually since changed the title of it because I got a bit of space to think about this a bit more, and then I started actually reading more closely capitalist theories, which was a very rewarding but also really scary experience for me. And unfortunately for my dad, who had to hear all the scary stuff, I had to stay down the phone about capitalism and Treadmill of Production. But today what I want to talk about is how we're spending our research and development money, both publicly and privately, in terms of whether we're putting it towards what Chris might refer to as alternative imaginaries, or what Nicole might call trickster research type, whether that's being funded in the agricultural space, and if so, in what ways is it being funded? And that's where my research is working. So this is more just an overview of some of the trends in agricultural research and development, and a sort of a move towards thinking about future research I might do in this area, scoping out the issue of how we're spending our agricultural research and development finance. So my main points for today, and I'm going to try and go under the 20 minutes, but my main points for today are really that key actors in the capitalist system have constructed a need for industrial agriculture to continue. Now, industrial agriculture is that large scale, high input, mechanicized, low biodiversity type of farming. Only a few varieties are what we rely on for our food supply. So that's the type of farming I'm talking about, and I'm looking at how this type of farming is constructed as having to continue in order to have food security. And then the other aspect of what I've been thinking about lately is how capitalist processes lock in this form of development and research, and how we need to be thinking about challenging this through how we publicly spend our research and development finances. So just a brief overview, and it really aligns with what Michelle was talking about as well. In terms of how we understand power and capitalism in the food system, there's three key periods of time that researchers have singled out. I'll just mention these quickly. So you have the British regime, which is obviously where large-scale agriculture was brought to colonial states. It was export-oriented, mass production focused on commodities that the British and other colonial empires wanted to consume. Then around the 1945s, and these are rough dates, but sort of rough transitions of power and time, you had the US regime come in. There's kind of two key aspects to the US regime. The first is that they invested a lot in industrial agricultural techniques, and the second is that they shared this widely through what we call the Green Revolution, but it's actually a series of initiatives that the Rockefeller Foundation, along with other US actors, exported largely to Southeast Asia and Africa. So we had a transferal of industrial agriculture largely from the US, but to a lesser extent the EU. And now we have what people are calling more of a corporate regime. It's not completely controlled by corporations because state actors still have a lot of power, but we have this market liberalisation process at both domestic and international levels that have given corporations more power in the kinds of foods we produce and how, and the kinds of diets and food choices we have available to us as well. So as a result of this corporate regime, we've seen a concentration of power in a few corporations, and I'm sure some of you are across the statistics, but just as an example, the same 6 multinational firms control 75% of all private sector plant breeding research, 60% of the commercial seed market, and 76% of the global pesticide sales. So you have a really big convergence in pesticide companies and seed companies, and a lot of their finance is focused on seeds, genetically modified seeds, or what they call it different names now, like CRISPR technology and other words like that. So, but essentially talking about genetic modified seeds and pesticides. And what this corporate regime has really done is reinforce that capital-intensive, medium and large-sized farms, because we need standardised outputs to feed a more corporate-driven, mass production, standardised product regime. So obviously low biodiversity, I won't go through that. And we've seen this reflected in agricultural research and development trends. So I just want to go through a few of these. So the first key trend is that investment in agriculture is very low. It's considered an underinvestment, so 5% of worldwide investment in all forms of research and development was directed towards food and agriculture in 2011. Now, the reason the statistics are a bit older is because that's the latest, that's the most recent study that was done on that. So it might have shifted, it might be more now, given that that was 2011, but there's still this discussion about underinvestment in agriculture. Except for countries like Brazil, India and China, where we've seen an increasing amount of investment in seed and pesticide research. So the second aspect is most countries have relied on the spillovers of knowledge and technology from Japan, US and the EU. In fact, the gap between poor and rich countries in per capita spending on public research and development has widened from 7.7 in 1980 to 11.7 in 2011. So you can see a widening as a result perhaps of an increased private investment in agriculture, where there isn't as much incentive to invest in, say, in developing countries or low-income countries, as there is to invest in high capital-intensive agricultural, highly profitable types of agriculture in developed countries. Okay, so another key aspect is that agricultural research and development since around the 1980s has really largely focused on pesticides. And the reason for that is pests co-evolve over time, so we're continually racing against the co-evolution of different pests. And as a result of that, a lot of agricultural research R&D has been focused on pesticides and coming up with a new chemical to address another species that has developed some kind of resistance. A second aspect of this focus has led to genetic modified seeds, and most genetic modified seeds, I think it's around 90%, 98%, it might even be more than that, have really been focused on pesticide resistant crops. So crops that are resistant to particular weeds, and you can spray them liberally without them being affected, and you can directly get the weed. So even biotechnology is an extension of this continued fight against pests and diseases, and the continued evolutionary process there as well, which you could say is a bit of a fighting a battle that you're going to lose, kind of like anti-aging products. Okay, so the last aspect is that it's increasingly privatised, and that won't be surprising, but in both high and middle income countries, the share of agricultural research and development by private companies is increasing, so it's roughly half-half. Universities and governments have not kept up with this, but those figures don't include public and private research partnerships, which are actually generally factored under public research, even though they're public-private collaborations. So you could even suggest that the private funding of research in agriculture would be substantially more if you factored those in different ways. So we've seen a number of joint ventures, for instance, between the CSIRO in Australia and the world's largest seed companies. And I have been understanding the issues in food and agriculture largely through a treadmill of production lens. And it's especially related to this idea of pesticides and the co-evolution of pests, and how we continually have to be developing new technologies to address them, and how that continues to lock us into an industrial agricultural model. So the Treadmill of Production is a neo-Marxist theoretical framework for understanding the linkages between capitalism and social and environmental harms, and it comes from environmental sociology. It refers to general trends in entire economies, so obviously specific institutions, specific actors might not be following this trend, but it is particularly applicable in the agricultural sector. So the underlying assumption of the theory is that capitalism needs to be constantly expanding production in order to maximise profits, and in order to expand, increasing amounts of environmental resources will be needed to be used and added to the environment as well. Consumption must increase as a result of greater amounts of production, otherwise profits will not be made. You could perhaps draw some connections there with the obesity epidemic. I'm not saying that it's completely attributed to the overproduction or overprocessing of food, but it's certainly a factor. in this understanding, those who control production, which are largely in the food system, increasingly so corporations, they're the primary agents driving the treadmill, and states and workers are positioned more as facilitators of this ongoing continued structure. So in terms of capitalist food systems, we can see that farms are operating more like factories than what it really is, which is humans interacting with nature to create food generally. So you have a set number of inputs to extract standardised outputs, and you have this reliance on intensive, mechanised, chemical-intensive technologies to produce food, which in turn makes costly withdrawals of our soil and our water, for instance, while adding chemical inputs into the environment. So it's the perfect, the treadmill of production theory really does align quite well with the issues that we're seeing in capitalist food systems. One other point I'd like to make in here is that a lot of the technologies that have been developed from agricultural research and development are focused on reducing labour. So the focus on pesticides is reducing the people that you need to hire to remove pests. Now that not everyone wants to work in agriculture, I certainly wouldn't want to work in a field. I mean, this skin, I'd get burned. But there is something concerning about the development to some extent of agricultural robots in this space and other kinds of technologies that are focused on reducing labour, and that is a continued trend in agricultural research and development. So at the same time, you could say workers don't want to work in agriculture, and that's why we need agricultural robots. Obviously, that is more of an argument in Australia than it would be in those economies that are more dependent on agriculture, which is more low-income countries. But still, there's an interesting question here about whether we want to invest in research and development that will cut more labour out of farming. So ultimately, the treadmill of production theory tells us that even the best performing capitalist food systems is not going to be socially or environmentally sustainable, or whatever other word you'd like to use to describe it. This economic system is completely at odds with the kinds of diverse food systems that we need to be more resilient to the effects of climate change. We also have a similar theory from agricultural economists about the technological treadmill that says that as farmers, early adopters of a new technology, produce more, that reduces the price of the crop that they're producing, and that in turn squeezes more farmers into adopting the new technology so that they can produce more and sell more, because now the cost of the product is less, so they need to sell more in order to actually just break even. So you have, as people adopt new technologies, more farmers in the same commodity have to adopt the same new technologies, and they're stuck in this treadmill of when a new pesticide comes out, a new crop variety, they have to adopt it or risk being uncompetitive and essentially, having to leave farming. So Rob Pekin often talks about how he was squeezed out of the dairy industry. So he runs Food Connect in Brisbane, which is a small-scale agricultural retailer, I guess, is how I describe it. So we can see this kind of dynamics playing out, we can see it play out in fertilisers, synthetic fertilisers, and we can see it with pesticides, but I've been particularly focused on the GM varieties because the law is particularly, I think, interesting there, how we've managed to expand intellectual property to take more ownership over genetic materials, and also the struggle that has or the injustice that causes for Indigenous communities. But this development of genetic modified crops really does reflect the treadmill of production model, and it deepens the critique that current agricultural research and development is reinforcing capitalist food systems that are really counter to combating climate change. So companies have accumulated and commodified genetic resources via private research developments and by lobbying for and taking advantage of expansion in intellectual property rights. As well as the conditions that they use through contracts that they place on farmers. And as we've discussed, with the way that some farmers in commodity crops will be forced to adopt a new technology, even if on the surface level it might appear that they have choices to adopt or not adopt GM, for instance. So the development of GM technologies has acted, again, more like a labour substitute than anything else, similar to pesticides, similar to what we might see with agricultural robots. It has enabled farms to substitute the GM crops for labour-intensive weeding practices, and the input in these cases is the GM seeds and technologies used to produce them. So there's two common related claims that I will just briefly mention that relate to climate change. So the two common ones are that we need to invest more in the development of GM varieties because they will increase yields despite changing climates, and they'll reduce pesticides, which will then increase the resilience of surrounding ecosystems to climate change. We really need to water down that messaging, and it's not completely incorrect, it's just not broadly correct. So it depends on the farm, it depends on the context about whether GM crops will actually increase that farm's yield. And I'll get into whether increasing yields actually does address food security, but in terms of actual on the farm level, there's mixed results, and it's hard to know for sure because researchers and the different, I'll look up a study, it'll say something about yields increasing for a particular, and then I'll look at who the researcher is associated with, and I'll come across claims of them being involved with either an environmental group or a big farming body. So it's conflicting, it's not clear, and it's certainly not guaranteed. In terms of reducing pesticides or any type, including herbicides and insecticides, GM crops have largely been unsuccessful, I could say that, in reducing the amount of pesticides that we use on crops. So largely, I mean across the board, not specific farms or specific examples, but generally we can say that based on a number of different studies. So those claims aren't necessarily true. And also another point to make is that we don't need to increase production for food security because we already produce enough food, but yet we have 190 million people who are food insecure and 2 billion who are micronutrient deficient. So the issue with our food systems is not a lack of food, it's a distributional one, it's the types of food that we're producing, it's how we're processing them. So the idea that we need GM crops to shore up food security is a common one, but it's completely unfounded. And even the Food and Agriculture Organization says, even if we don't need big advances in biotechnology to meet expected demand of future generations. Now, what I find interesting about the expected demand figure and the figures that people throw around about needing to increase production by 70% is that they're based on the diets that people have now, which are meat-intensive diets, and they also don't consider, a lot of the time the figures don't include fruit and vegetables, and they don't include food waste if we reduce food waste. So there's a number of ways that we can increase or address this demand in the future that that don't involve increasing production, that involve shifting diets towards something that's more healthy and sustainable, for instance. Now, agroecology is the sort of counter movement, I guess, to large-scale monoculture industrial agriculture, and it's naturally transdisciplinary, so it combines traditional Indigenous local knowledge with participatory models of research, and then a range of different scientific and social science disciplines to come up with a range of low-input farming practices that essentially manipulate the environment in ways that, or mimic ecosystem services to create foods. So it's nothing dramatic, it's things that you're probably already doing if you have a garden. I mean, some things anyway, like mulching, using manure, but then it could involve, for instance, using crops that have really deep root structures, planting trees along the border of your farm. So there's a range of studies behind it that show that it will increase production in a lot of cases while helping increase the soil carbon content. So soil is absorbing more carbon, which is a greenhouse gas, so combating climate change. So I won't go through, I've got a range of studies that I could talk about, but I think I'll just point out that I guess the reason agroecology is an important alternative that we should be investing more into is that it avoids carbon by preventing soil erosion, it increases that soil carbon content. Because it's focused on not using pesticides, it delinks food production from this reliance on fossil fuel energy, so you use a lot of fossil fuels to create pesticides and synthetic fertilizers, and it also strengthens resilience to changes. So for instance, if your soil is healthy, it stores more water, and then if a drought occurs, it's more resilient to the drought. Just a broad example. So in closing, I'm interested, I found this US study that looked at how well agroecology was funded in the US in 2014, and around 4% of the projects that were funded out of 836 were broadly related to agroecology. So they had an agroecological component, whether that be reducing pesticides through, integrated pest management or something like that. So that study is the first one that was done, and it was in the US. And I'm thinking that I might be able to replicate that study here because it was qualitative, not quantitative, or largely qualitative anyway. And the area I'm thinking about moving into with research and development in agriculture is looking at scaling up these other kinds of research programs and how we might better use that within universities. So thank you.